Good day, guys. Welcome to Calcumind, and today we'll be looking at Newton's law of cooling, which is under the application of ordinary differential equation to both science and engineering. So, this is a formula which relates the heating and cooling of a body with respect to the change in temperature. So, now this is the change in temperature with respect to time, and whereby this is the temperature of the body and this is the constant temperature of the surrounding. So, now this varies directly. These parameters here, whereby the temperature changing with time, varies directly with this. So using our knowledge of variation, we can do dt. You'll be asking, why are we using minus rather than a plus? We'll be attempting a sample problem which says that a body with an initial temperature of 160 degrees is in a room of constant temperature of 30 degrees Celsius. If the temperature of the body falls to 140 degrees Celsius after 20 minutes, derive an equation for the temperature of the body at any time t. Secondly, what is the temperature of the body after 60 minutes? Thirdly, what will be the temperature? When will the temperature fall to 35 degrees Celsius? They are tasked to find the time and also temperature. So now we'll start first by deriving the equation. So this is the constant equation whereby this is going to be the constant temperature of the room, and this will be the changing temperature as regards to time. So firstly, we are presented that the constant temperature, which is the room temperature, is 30 degrees. And theta t for the first, let's call it theta t1, for the first change is equal to 160 degrees. Then the material also mentioned for a second change in time. Let's call that theta t2. Second change in time, which was 20 minutes, the temperature dropped to 140 degrees. So theta t2 is going to be 140 degrees Celsius at t equals to 20 degrees Celsius. So these are like boundary conditions in which we solve for the individual constants. So firstly, we are going to be imputing this into the equation and solving for the model equation. So now we impute 160 over here, and earlier I told you that 30 degrees remains constant, so it's going to be placed here. So this dt. Now using separation of variable method, we are going to be taking the values of t to one side and the values of theta to one side. So now we are going to be cross multiplying. So this will be minus k. This goes to this and this goes to this. This is all divided by 1. So this dt theta t minus 30d multiplied by dt is equal to the theta. So now on this end, k is a constant and it does not have any t, and dt is a constant. The most logical idea now is to remove anything that has theta. We don't want anything that has theta to be on this end. So we'll take anything that has theta over to the theta side. So now we are going to be dividing through by 1 over this. So we'll divide through by 1 over, divide through by theta t minus 30, or we'll multiply through by 1 over this. So we should get the idea. So this minus k, we can see that if this eliminates this has t on one side and this has theta all on one side. So that is the basic idea we are going with. So this minus k dt is equal to 1 over theta t minus 30 d theta. So if you're lost in this whole process that we walked through, you can go back to our previous video that we worked on under direct integration and separation of variables to get a better idea of how we arrived to this point. So now we are going to be integrating both sides. So we are going to be integrating both sides, whereby we are going to be integrating this constant minus taking any value that is a constant outside the integral sign. So this minus 1 minus k dt is equal to the integral of 1 over theta t minus 30 dt. So if you integrate a constant, you're basically adding the variable that you're integrating against to it. That is a lot of grammar for saying if you integrate 5, it's going to be 5x. If you integrate k now, it's going to be kt. So this is minus kt. So now we are going to add our integrating constant, which is c, and it's going to be, if we integrate 1 over x, it's going to be ln x. So now integrating this is going to be ln theta t minus 30. So that is the idea we are moving on with. So now we have been able to establish this equation, and we want theta to be the subject of the formula. We want theta to be like the reference point in which we are looking at this whole equation. So now we are going to be taking the exponent in order to eliminate the ln function. So let's take in the exponent. So we'll take the exponent of both sides. Anything you do to the left-hand side, you're going to be doing to the right-hand side. In order, that is the rule for balancing out mass equation. So we're taking the exponent of minus e k plus c is equal to, if you take the exponent of a ln function, it's going to cancel out. It's going to be theta t minus 30. So now using the laws of indices, whereby EA plus B is equal to EA dot EB. So this is basically an addition rule whereby EA plus B, the powers can separate into a multiplication of both bases. So now it's going to be E minus KT minus 30. So EC, let's just call it an A. EC is equal to A. So now we are going to be substituting it in the equation. Okay, so we had the conditions earlier, t equal to 0. Theta was equal to 160 degrees Celsius. So when the second condition was when t was 20 minutes, it dropped to 140 degrees Celsius. So now let's substitute it into this equation to find the value of A and also find the value of K. So we'll substitute t equals to 0. So E minus K 0 is equal to, theta is what? 160 minus 30. So this E raised to power 0 is equal to 130. So anything raised to power 0 is 1. So A is equal to 130. Secondly, we are going to be finding the value of K using this second condition. So now, to find K, we'll put 130 E minus K, whereby T is 20. So T is 20. T is 20 and our theta is 140. So this is 140 minus 30. So this will be 130 E minus K 20. So this will be 140 minus 30 is 110. So now, to make K the subject of the formula, I'll divide by 130. So this is dividing by 130. Dividing here by 130. So let's do that. It's equal to E minus 20K. So now we'll be taking ln of both sides. I told you in order to cancel the exponent, you take the ln. So this minus 20K ln 0.85 So in order to take out the 20, the k, in order for the k value to stand alone, we'll divide by minus 20. Ln 0.85 divided by minus 20 is giving us k is equal to 8.125 times 10 raised to power minus 3. So now let's write out the model equation. Our model equation is present as 130 e raised to power 8 times 10 raised to power minus 3 t is equal to, okay, for question 2, they were like, what will be the temperature of the body after 60 minutes? So this has a minus over here. We forgot our minus. So this will be at theta t, we don't know our temperature, but they gave us our time, which is equal to 60 minutes. So at 60 minutes, we should find the temperature. So now let's put t equals to 60 into this equation and work out the value. So this is 130 e minus 8 times 10 raised to power minus 3, all multiplied by 6. So now let's work out this equation. This is giving us 130 multiplied by 0.62 is equal to theta t minus 30. So now 130 times 0.62 is giving us 80.6 plus 30, which is equal to theta t. So this is going to be giving us 110.6, which is equal to theta t. So now at t equals to 60 minutes, our temperature is 110.6 degrees Celsius. So for question 3, they were like, when will the temperature fall to 35 degrees? So they gave us t equal to 35 degrees Celsius. So they were asking us for the time. We don't know the time. So using our model equation, which is 130 e raised to power minus 8 times 10 raised to power minus 3t is equal to theta t minus 30. So we'll plug in 35 into this equation. So this is 130 e minus 8 times 10 raised to power minus 3t is equal to 35 minus 30. This is 130 e raised to power minus 8 times 10 plus t is equals to 5. So now we are going to be dividing through by 130. So 5 divided 130 is 0.0385. So now we'll be left with ln minus 8 times 10 raised to power minus 3t. So now we are going to be taking the ln function of this to eliminate the exponent. So if this is going to be ln 0.0385 is equal to minus 8 times 10 raised to power minus 3t. So let's take the ln function of this and check it out. This will be ln 0.0385, giving us minus 3.25. Now we are going to be dividing all to get the value of t. Minus 8 times 10 raised to power minus 3, which is equals to t. We'll be getting a value of t, which is equal to 407.14 degrees Celsius. So that is the final answer for this problem. Hope you like, share, and subscribe, and leave us a comment in the comment section. Thank you.